In this video, I hope to conclude my discussion of derivatives. At least now we're giving you some idea of how they actually work. And we're going to start with this equation right here. Now, I know that there are different types of notation for derivatives, and we'll get into that in a later video, but right now we just want to finish up our topic on derivatives, okay? First of all, we have an equation like this, and I hope you can see this. We have y1, which we said was an initial value. In other words, the starting point of our discussion. In other words, in this particular case, it would be a particular number of feet that a ball has already dropped. Okay? And then we have the change in y. We don't know how many further feet the ball has dropped. Okay? But we already know that the ball has dropped a certain number of feet. That's where we get the y1. And then this is the number of feet that it continues to drop after that. Alright? And then we have this A over here. And then again we have the initial value. This here, this x1, is the number of seconds that have already elapsed. This is almost a past tense here. And this is what's going to elapse after that. Okay? So you're going to have a number of seconds you're going to start out with, which is say 5 or 6 or 7, doesn't matter, okay? And then this is an additional amount of time, and this could be a half second, this could be a full second, it could be whatever. Now, the thing I want you to notice on this change in y and this change in x is that in a normal circumstance, both of these would be 0, but we already know that if we put 0 in either one of these spots, or actually both of them in this case, that what you're going to end up with is a division problem which you cannot solve because these two values are 0. So actually, the change in y and the change in x in this case is going to represent the absence of value, or otherwise known as 0. And I talked about this in a previous video. Okay, so we have two zeros right here, but we're not calling them zeros, and the reason why we're not calling them zeros is because you cannot divide by 0. So we're going to assume that there's some kind of a value here, some kind of a value here. Now, we're going to factor out this equation right here, and when we do, we get this. We get this equation right here, and then we multiply every one of these terms. See these terms right here, the x1 squared, the 2x1, delta x, and delta x squared. We multiply all this by the letter A. And then we get this equation right across here. Now then, we're going to divide the entire equation by delta x, which is right down here. Now remember, as I said before, we're letting delta x represent 0. Even though we could never physically divide by 0, we can divide by delta x. And so delta y divided by delta x, which is the change in y divided by the change in x, gives us this equation right here. Now then, we have this equation right here. You can see right down here, delta y divided by delta x gives us this. And then we're saying that if x were 0, we would get this value right here. Now, I bet you remember from a previous video when I discussed tangent to the curve. Remember I said that a circle can be touched at one point by a tangent to the curve. And we started using secant lines to find that tangent. And hopefully you remember all that. If you don't, you need to go back to a previous video and find out what I'm talking about. This here, this final whatever right here, this limit where x is getting close to 0, is this. This is the tangent to the curve. That point is the tangent to the curve. And that's what we've been trying to find using derivatives. So we have actually derived a value out of another equation where that value could end up being 0. Okay, so we're saying when x is 0, then that's the point on the curve. Okay, And at that point, the equation becomes unsolvable. And that's where derivatives come from. Alright? That's why we said there's a limit. There's a limit to how well this equation is going to work, because at a certain point x becomes 0, and so therefore the equation can no longer be solved, because that's the equivalent of trying to divide a Thanksgiving turkey without a Thanksgiving knife. Kind of absurd. But it does give us instantaneous speed. So when we're talking about instantaneous speed, we're talking about a speed that is less than a nanosecond, which would be an absence of time. An absence of time is, of course, 0. Okay? So we're trying to find a rate of speed, an average rate of speed at a period of time which is 0. And of course, if you were to use 0, you would never find it, so therefore. Hopefully that explained derivatives to you. We will be getting into far more complex equations in a future video. I will discuss derivatives in a different video series in the near future. So this discussion of derivatives in itself is not over, but the basic concept of derivatives has finally been presented to you. And now you're beginning to understand. At least I hope you're able to understand. Alright, I will tell you more in a future video, so stay tuned.